Hey, this is Mr. Aiden. This is section 2.6, rational functions and asymptotes. So we're going to be doing some work on rational functions and asymptotes, and you might be asking, what in the world is a rational function? What in the world is an asymptote? So let's answer those questions. So a rational function is just one that has a numerator and a denominator. It's a function that has the numerator on the top, the denominator on the bottom, and you can see the domain or the x values, the independent variables. That's what a domain is. The domain of a rational function of x includes all real numbers except the values where the denominator is 0. So if the denominator is 0, that means that is where your domain is limited. Your domain you do not have a value for your domain or your independent variable if that denominator is 0. And that makes sense. If that denominator is 0, it is an undefined value. So if you can take a look at this graph. This function is 1 over x. And you can see this 1 over x. You can see your domain can be all real numbers except for 0. Do you see how 0? You can't have a 0 here because 1 over 0 is undefined, isn't it? Undefined. And so this graph is not continuous. It doesn't continue in one straight line. And so let's use some of the language that we've talked about so far. The limit as x approaches negative infinity of this function, can you see as we go towards negative infinity this way, we're getting closer and closer and closer to the y value of 0, aren't we? But take a look over here, the limit as x approaches infinity, as we keep going towards infinity of this function, we're getting closer and closer to 0 as well, which means there is what we call an asymptote, what we call a horizontal asymptote. Our values can't be 0 on the y-axis here. Okay, but also take a look at your x-axis here. We have what's called a vertical asymptote here. A vertical asymptote. We can't be this x is equal to 0 right here because we're undefined, which means my domain, and we're going to. You've been using different terminology for domain to find a domain in past math courses. Maybe you've found from negative infinity all the way, x can be all the way to 0, and then from 0, x can be all the way to infinity. Okay, which means, what that means is this first thing says that your x values can be anything from negative infinity all the way to 0, but it's not less than or equal to, so it's not including that, and then from 0 all the way to infinity. We're going to use a little bit different terminology in pre-calculus, or notation per se. We're going to say we can go all the way from 0 to, from negative infinity. My bad. We'll start over here. We can go all the way from negative infinity to 0. And this is a parentheses because it does not include 0. If it was a bracket, it would include 0, but it's a parentheses. And we're going to go union 0 all the way to infinity, which means this basically says all real numbers except 0. Okay? And so some different things. Here, take a look here. Let's try to find out our vertical and horizontal asymptotes. We have a horizontal asymptote at y equals 2. Okay? At y equals 2 is what we call a horizontal asymptote. But our vertical asymptote is here at negative 1. Okay? So x is equal to negative 1. We call that a vertical asymptote. And so this is where our values can be. So we can't be y equals 2, we can't be x is equal to negative 1. We have vertical and horizontal asymptotes. And so if we took a look at what is our domain, our x values can be all the way from negative infinity. We can go all the way to negative 1, can't we? And then we can go from negative 1 all the way to positive infinity. Those are our x values, or our domain right there. Let's take a look at how to find vertical asymptotes, okay? Or let's just see if we can find our vertical asymptotes here. So how do we find vertical asymptotes is set that denominator equal to 0. Okay, so we take this denominator, we have 3x squared plus 1. we're going to set this equal to 0. So we have 3x squared is equal to negative 1. We're going to move the negative 1 over. We're going to divide by 3. X squared equals negative 1/3, which means x is equal to plus or minus square root of negative 1/3. That's not a real value, which means there is no vertical asymptotes. There's no place vertically that we can't be, which means you can see our domain is all real numbers. Our domain is going to be from negative infinity all the way to infinity, which means all real numbers. Let's take a look at this second example here. Let's set this denominator equal to 0. So if you want to find a vertical asymptote, set the denominator equal to 0. So we have x squared is minus 1 equals 0, which means x squared is equal to 1, which means x is equal to the plus or minus the square root of 1, which is plus or minus 1. So you can see how right here, ding, 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 negative 1, ding, 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 positive 1, we have vertical asymptotes. Yay! We found our vertical asymptotes, which means what is our domain? Our domain goes from negative infinity all the way to negative 1, from negative 1 all the way to 1, from 1 all the way to infinity. So all real numbers except for negative 1 and positive 1. And so that is how to find a vertical asymptotes. How do we find vertical asymptotes? We set the denominator equal to 0. So we can also find vertical asymptotes and holes. And you're like, what's holes other than that good book or movie? So let's take a look at our holes. We're going to factor the numerator and we're going to factor the denominator. Okay, so let's factor the numerator first. X times x equals x squared. What's the factors of negative 2 is positive 2, negative 1. On our denominator, what's the factors of x squared is x and x. What's the factors of negative 6 is negative 3 plus 2 right there. And so how do we know where our vertical asymptotes are? Or our holes where we're not continuous is set the denominator equal to 0. So, but do you see how we have something that cancels out here? We have x plus 2 canceling out. Whatever cancels out is going to be what we call a hole. So you see x plus 2, or x is equal to negative 2, is where there is a hole, which means right here there's a hole. Now you might say, Mr. Reed, how come on the graph it doesn't show a hole? It's because this hole is infinitesimally small, which means there is a hole right here at negative 2.0000000000000000000000001. There's a point there, okay? But infinitesimally small hole, there is a hole right here. It is not continuous. It is not continuous right here. There's a hole. So whatever cancels out, there's a hole. Look at the other one is x minus 3. We can set that equal to 0, which means x is equal to 3. There must be a vertical asymptote. So what does not cancel out is your vertical asymptote. What does cancel out is the hole. And so we are able to find out our domain this way. What is our domain? Our domain starts off at negative infinity and goes all the way to negative 2. But there's a hole there, isn't there? So we can't include negative 2. So that's why we have our parentheses. Union, negative 2. We go from negative 2 all the way to positive 3. And then we go from 3 all the way to infinity. So again, all real numbers except for this hole right here at negative 2 and the asymptote at positive 3. So what cancels out when you factor is going to be a hole. What doesn't cancel out is going to be a vertical asymptote. Now you might say, Mr. Reed, you've talked a lot about vertical asymptotes. How do we find horizontal asymptotes? Well, it's really easy. With horizontal asymptotes, you look at the degrees. If the degrees are the same, do you see how we have an x squared on our numerator and an x squared on the denominator? Those are the same, which means you are going to take the coefficients of those guys. Do you see the coefficient of this x squared on the numerator is 3. The coefficient of this x squared on the denominator is 1, which means we have a horizontal asymptote at 3, or what we call y equals 3. So there is a asymptote right here, as you can see. Does that make sense? So if the degrees are the same, You're just going to take the coefficients, and that's your horizontal asymptote. If the bottom degree is bigger, remember this is really like x to the 0 power, isn't it? See how the bottom degree is larger, x squared. So if the bottom degree is larger, then the horizontal asymptote will always be y equals 0. Will always be the horizontal asymptote. So if we have x to, if it was x to the first power over x squared, if it was x to the 0 power over x squared, if the bottom degree is bigger, y equals 0 is always going to be a horizontal asymptote. And if the top degree is bigger, then there is no horizontal asymptote. So there is, in this problem, there is no horizontal asymptote for this. And so if they're the same degree, you just do the coefficients. If the bottom degree is bigger, y equals 0 is a horizontal asymptote. If the top one is bigger, there's no horizontal asymptote. So let's do one last example maybe. Is we're going to find out the function's domain and its asymptotes of this value. Okay, so first take a look. First, we want to take a look at the denominator. We're going to set this denominator equal to 0, so negative 4x cubed plus 5. We're going to set this equal to 0. So negative 4x cubed equals negative 5. The negatives cancel out. So we have 4x cubed is equal to 5. We have x cubed is equal to 5 fourths, which means x is equal to the cube root of 5 fourths. The cube root of 5 fourths. So this is where we are not continuous. So the domain, what would be the domain? The domain is all real numbers except for this guy right here, which means we're going to go from negative infinity all the way to the cube root of 5 fourths, and then from the cube root of 5 fourths all the way to infinity. That would be our domain. Okay? And so that is where we have, and also, not only is that our domain, but that's where we have a vertical asymptote. That's where we have a vertical asymptote. It's not canceling out on the top and the bottom, so that's where we have a vertical asymptote. This is about 1.08 or so, 1.08 if you look on your calculator. Now let's take a look at the horizontal asymptote. So the horizontal asymptote, remember, I'm going to look at my degrees. I have an x cubed, I have an x cubed. They're the same degree, which means I'm just looking at the coefficients. Y is equal to negative 3 fourths, and that is my horizontal asymptote. And so I could easily use these to sketch out my graph. Okay, and so that is finding the function's domain, its vertical asymptote, its horizontal asymptote. And this is Section 2.6, Rational Functions and Asymptotes. Have a good day, guys.